Okay, so next we are looking at moving towards a purely open aosp. As you've probably all seen, there's always some components of aosp that are not really quite open, and that is something we should really be trying to fix. So aosp is a nice start, but it's not really complete, and unfortunately this even tends to get worse instead of getting better. Like in early versions of aosp, it included an email client, which I'd consider base functionality for any mobile, but that got removed in favor of using non-free tools. And the launcher got pretty much stalled, getting pretty much no attention since the start of the Pixel launcher. The browser that is in the Android source code is not really usable. And at the same time, expectations of functionality that we just expect to be present in every device is growing. So instead of removing components, we need to be adding them. And often aosp isn't getting it, and only Android phones get it through Google or other vendor apps. So the question is, can we still build an open source phone? And if yes, how can we do that? We'll start with some fairly simple things and then get to the interesting part. Obviously, the simplest thing is just adding a couple of apps from third-party sources that replace all the stuff that you would just get as binaries on your existing phone. And I'm going to mention the apps that I think are best to put in your fully open aosp build. Obviously, they're not the only ones that exist. Maybe I missed a better option somewhere, so do your own research instead of blindly trusting me. First thing that you will probably need on a browser, on a phone, is a browser. And it is best to use some version of Chromium. There are a couple of alternatives to it, but they don't implement the APIs that you need to replace the system web view, which is essentially a stripped-down Chromium that is going to be embedded into apps, for example, when they want to display their HTML code. And you won't notice that this is missing in a fully open build, because it's included in aosp sources, but as a pre-built binary. So if you want to go fully open, you have to rebuild that, and only Chromium and closely derived browsers can do that. If you have concerns about privacy, if the reason why you want to build an open phone is that you don't trust Google, that they might be stealing your data, you can use the ungoogled patches. I've actually done that on one phone and it works nicely, so there's no trust issues even if you're using the Chromium code base. Next is you'll need a mail app. K9 Mail is probably the best way to go there. It's originally based on the email application that was part of the early aosp builds when it still had one. And from then on, when it got removed, it now has 17 years worth of improvements. And these days it is also known as Thunderbird for Android, but it doesn't actually share the code base of desktop Thunderbird. It just shares the name, so don't get scared that it will pull in 500 megabytes of dependencies or stuff like that. It doesn't. Next is maps. Obviously the challenge there is to have something that will still have accurate maps of all the roads and trails and everything you might find. I found two pretty interesting replacements for maps. One is Organic Maps, uses OpenStreetMap data, and in many ways it's even better than Google Maps. It has more complete offline support, like you can just, if you have the storage, download maps of the entire planet to your phone. And, you get not just the roads, you also have hiking trails, contour lines. If you're enjoying outdoors activities, it's much better than Google Maps for that. And another option is Osmond, which also uses OpenStreetMap data. And it's also a good choice. It is pretty good at navigation, but if you want a fully open build, you have to be a little bit careful because it includes some non-free artwork. So you may have to replace a couple of icons and a couple of markers that will be drawn on the map. But the code base itself is open, so this is certainly another good starting point. Next we'll need a media player. There's at least 2 good options for that. MPV Android, which is based on MPV and FFmpeg, can deal with just about every format you might run across, but probably doesn't have the best support for hardware-based acceleration decoding. And then there's VLC Android, the Android port of the VLC player probably everyone has seen. That also works pretty well for this task. Next, most phones that you see in the shop have a weather widget. We have one in the open source world as well. This is Forecasty. This one I could find that works pretty reliably. And you can also put it on the desktop as a widget. So you get pretty much the functionality you'd also see in a Samsung phone or so. Next is the launcher. While aosp still includes one, it hasn't been getting all the features lately, and it just can't compete with the ones that are in real Android phones. So fortunately there's already a couple of forks of it that do a better job at keeping up to date with the features that work pretty much like the Pixel launcher. So there's Launcher, there's Bliss Launcher 3, about which there will be another presentation here a bit later. And there's one I won't even pronounce because I have no idea what language the word is from. But the code is open and it also seems to be a pretty good option. And then last thing, we need a way to get more apps on it. We need to replace the Play Store. F-Droid has become pretty much the agreed upon place to go for all the open source apps. So you certainly want to build that into an open phone. And if you also need non-free apps, if you just say the system itself should be open source, but it's not a problem if the apps on it aren't, there's some way to pull those in as well. For example, AppDroid and APK Mirror are pretty good places to just find the non-free APKs that you can install to get those apps. And the APK Mirror client app is currently unmaintained, so maybe there's a volunteer here to take it over, but it's still pretty useful. So now that we've covered the apps, we get to more interesting parts. Next step is a lot of the apps rely on cloud services and you want some connectivity to the rest of the world. And of course, in the fully open world, you don't have those pre-included with aosp. Fortunately, you can replace Gmail with a standard IMAP and SMTP server, just use postfix and Dovecot or similar things. For Google Meet, you can use Jitsi. For Google Drive and Calendar, you can use Nextcloud. And the Nextcloud app also automatically uploads photos to your own storage. So you can get rid of any dependency on not necessarily trusted services. And you don't need to modify the camera app to do this because Nextcloud monitors the directory in which the camera app puts its files. So you don't need to use the modified camera thing from Android. You can just use the aosp camera or another camera app like Open Camera. Well, then there's the problem that you might not have servers running those things already. But fortunately, many of the open source projects that we've seen in the previous slide already offer hosted services, so you can go there. Or you can go to a provider like Federated that provides hosted versions of all those cloud services, and you get all the free versions of what you'd have in terms of Google integration in an Android phone. Okay, now we are getting to the very interesting parts if you start removing all non-free bits of the aosp. So now you've removed all the non-free bits, you've added all the apps you need, you've replaced the cloud services, but then half the non-free apps you install through AppToid or APK Mirror or some other source will fail. And the reason is because they use Google Mobile Services, which is a pseudo-standard library that integrates Google services like finding data from a map or getting your user data, stuff like this. But fortunately, we have a solution for that as well. There's an open re-implementation of pretty much all of GMS. It might still be missing a couple of things, which you can find at microG.org. And microG does a pretty clever thing because those non-free apps keep checking for security reasons that they're talking to the real library. So microG needs a way to trick them into thinking that they can talk to microG instead. It introduces a patch for signature spoofing, so apps would see the Google signature even when it's not there. Unfortunately, it has been done in a way that is secure. You don't open yourself up to getting your bank app signed by different sources and stealing your data, because with the signature spoofing patches that are part of microG, you can define in a read-only way what particular code is allowed to spoof a signature, so you don't open yourself to all sorts of backdoors by using this. So now we have a phone on which pretty much all the apps work, and you have replacements for everything that comes with core Android, but you'll notice your phone's battery drains much faster than it did with the non-free version. And that's because of a hidden setting. If you look in the aosp codebase, in framework space, core res values, config XML, you will find a couple of hidden switches. One of them is enable auto power modes, which is disabled by default in aosp and enabled by default in Android. The idea behind this difference is that in Android you have a couple of apps that are allowed to bypass power saving, like GMS generally bypasses power saving to check the cloud integration to give you a notification when you've received something. But in plain aosp, where this feature is disabled because it doesn't have a list of applications that are safe enough to bypass power management. This is simply shut down, and when the phone is in your pocket, the apps will not be permitted to communicate with the server to check for emails and the likes. But fortunately, you can just flip that switch to true, and then add a couple of files explaining which applications can do this. You can see examples of definitions for what apps can override power management by looking at framework space data etc platform XML. There you can see what is already done by aosp. Android adds a few more of those for GMS, and it's a good idea to do that in any open modification as well. You want to add com.google.android.gms to the list of allowed apps, even if you're not using GMS, because microG also uses Google Android GMS to identify itself, and you want microG to be able to override power management when necessary. This is what the file could look like to make sure that the apps you are using will have sufficient access to override power management and check for things in the background. So essentially it's an XML file where you just open the config and then you put tags allow and power save, which allows generally to do things even while the phone is supposed to be saving power. There's allow and data usage save, which allows to bypass data use limits, and then there's another one in the middle allowing power save except idle, which still allows an app to override power save, but not when it's completely idle. So that is a bit of a compromise between allowing it to draw more battery and allowing it to access what it needs to access. So now we have a fully functional phone, and all the closed parts that we've seen initially have been replaced, but it's unfortunately still not a fully open phone, because if you look closer you will find there's still a lot of closed source drivers, and unfortunately this is one point where I have to say we cannot get rid of all of them just yet, but we can reduce the number and we can get closer to replacing all of them. First thing to look at would be graphics drivers. We've had good successes building aosp versions with open graphics drivers. The Penfrost driver, which takes care of pretty much all modern iterations of the ARM Mali chipset, is known to work, for example, on the Kada Swim 3 board. You can find a wiki page at bero explaining how to do it. That also has a local manifest attached that will allow to just pull in the needed modifications. Freedreno is also known to work. That works for many Qualcomm chipsets. There has been a talk at the 2023's XDC about this, so I'm not going to repeat what those guys have already been saying. You can look at what they've been saying. It's been archived online. So what you need to do to integrate open graphics drivers, you need to rebuild the kernel, because closed source drivers usually have their own closed kernel modules, and the phone vendor kernels that use the closed drivers will generally not have their open equivalents enabled in the kernel. Usually while at that you want to use a newer kernel because those drivers keep getting better, but of course you might need some other patches to keep rest of the chipset in your device going. You need new device tree files, unfortunately, because while they refer to the same hardware, the closed drivers and the open drivers specify hardware parameters differently. So you will have to check what data your particular open driver needs to know, and then extract that data from the closed driver device tree files and put it into the right format and add it to your device tree config. You will need a Mesa build, which is pretty well documented. You will probably need a couple of patches to mini-GBM. It doesn't by default support all the pixel formats you might run into on a phone, but fortunately those patches keep getting smaller. So where do we still have problems? Some sensors are not very well supported yet. Some Wi-Fi and Bluetooth chipsets don't yet have open drivers. And bootloaders and TEEs. Modem drivers are a big pain point. Voice calls, even though probably nobody really uses a phone to make voice calls. If you are interested in working on those parts, there's a project called Replicant, which has beginnings of open drivers. Unfortunately, it is stuck on a really ancient code base, Android 6, and on really old phones like a Samsung S3. But it's still a good point to see how the APIs work, how to possibly write a radio interface there. So if someone is interested in doing that for a newer phone or newer device, it's still a pretty good starting point. Next, there's a problem with some pre-built build tools in the source tree. Those don't get on the phone, but they're needed at build time. While this is generally just builds of open source tools, unfortunately the fact that they are delivered as binaries in the aosp source tree means that you cannot build aosp on non-x86 machines at the moment. There seems to be some effort to fixing at least that later point. If you check out the main branch of aosp, in some revisions you can see the ARM64-based binaries. Unfortunately, that's not going to help if you're building on a RISC-V machine or so. So it would be really nice to have a way to rebuild those build tools. It shouldn't be complicated because they are all open, but yeah, somebody has to do it. With that, we're pretty much at the end. If there's questions or feedbacks, or maybe truckloads of dog food, let me know. And of course, you can join aosp-devs on the Discord to find all of us who have been organizing this dev room and get more information. Do we have any questions?
I know there's a few apps in, for example, Lineage OS that replace the calendar and the contacts in the phone app. Is there any chance that those kinds of apps could ever enter the aosp tree, or is that just a no-go because Google maintains that?
That's a good question. So the question is, there are additional apps like replacing the calendar and stuff in Lineage OS and other Android forks. Is there any chance that those will end up in the aosp tree at some point? I wish I could say yes, definitely. Unfortunately, I don't think it's currently very likely because the aosp tree is pretty much under the control of Google, and they don't really want those replacements for their binary things in because they don't want the additional workload of having to maintain another thing that's not going to be used in any of their devices. But of course, what we can do is put up a tree on aosp-devs or so, where you can just pull them all in with one call to a local manifest. So that's not quite as good as really upstreaming them into aosp, but it's a good compromise.
Yeah.
Okay, anything else? Yeah.
Sorry, do you know if it's possible to make a unified push work with the power saving and maybe make this configuration more user-friendly instead of modifying XML files to make it automatic, so a unified push provider could make it possible to go in with power saving?
So the question was, is it possible to improve the power save things to make it more configurable without having to edit those XML files? At the moment, the answer is there's no tool that does it, at least none that I could find. And there will be some problems implementing it because those files are on a read-only partition, so you cannot just change it at runtime and have a UI saying, okay, I want this custom app to do this, that would be accessible to the user. But there's really nothing that would prevent someone from patching it in.
Yeah, so the way right now is to integrate unified push providers into distributions, or how would it be possible to make that widely available?
Yeah, at the moment the only known way is to put those XML files into a distribution or force them in through sideloading or through ADB or the likes. Yeah, we're out of time, but if you have a quick question.
Quick, so what they were asking about, does Lineage OS still fall into the category of power saving being broken and not being set up? So if I wanted to get power saving properly on Lineage, I would have to with root edit those files at runtime, remount, read, write, and edit those files, right?
Yes.
Okay.
Yeah, I just got the sign saying please repeat the question. So it's about getting the power management stuff into the Lineage OS apps, and yeah, the way to do it is to add those files, put them into the build, or allow a user to install them through ADB.